The question reads, a particle moves along the x-axis so that at time t its position is given by s of t equals t cubed minus 6t squared plus 9t plus 11. And you probably noticed there's a couple things wrong with the one on the worksheet, so just note that it should be s of t and the minus 6t should be squared. So let's look at part A. What is the velocity of the particle at time equals 0? Well, first we need the velocity function. So let's take the first derivative of the position function, which is this one in white here that they've given us. So let's see. The derivative of s of t with respect to t is equal to, let's see, this is just strictly the power rule. So we're going to get 3t squared minus 6t plus 9. So now that we have our velocity function here, let's go ahead and substitute 0 in for t, and that'll answer part A. So v of 0 equals 3 times 0 squared minus 6 times 0 plus 9. So that's just going to leave us with 9, and we can call that meters per second. So this is our answer to part A right here. Now let's take a look at part B, and that's asking us, during what time intervals is the particle moving to the left? So we know the particle moves to the left when the function values of the velocity function are negative. So in this case, if you go ahead and graph this, you're going to get something that looks like this. Something like, kind of like up here. That's not perfectly drawn at all. I'll redo that actually, but alright, close enough. So, yeah, but as you could see, it never, this never goes below the x-axis, so that's going to tell us that we're always going to the right. We're never moving to the left. So that's how we're just going to answer that. So the particle, let's see, what did I write here? The particle is never moving to the left because the particle never moves left because the velocity function values are all positive. All positive. Okay. So that's going to answer part B for us. Now let's take a look at C. I'll do that in a different color. Alright, now part C asks us, what is the total distance traveled by the particle from t equals 0 to t equals 2? So we're looking at something like this. That's our interval. So what I just did for this is I plugged in s of 0 into the position function, because that's so it's going to tell us the distance. So I did, oh, my phone's vibrating. So I did s of 0, s of 1, and I pre-did these before making this video, so I want to waste time using my calculator. So s of 0 I got for 11, s of 1 I got 15, and for s of 2 I got 25. So our origin is 11, and this seems like a linear pattern here. So we could just say 25 minus 11 is going to give us our total distance traveled, and that's 14. So in this case, our total distance traveled is the same thing as the displacement. So total distance traveled, total distance equals 14. We'll be consistent with our units and call that meters. So that's it.